Hi, Assalamualaikum. I'm Muhammad Aiman Shah. In this video, I'm going to present the teaching through Tinkercad, which I'm going to demonstrate my own device, namely blood level indicator. In this video, I'm going to present in three parts. The first part, which is the process of making the device. The second part is the process of programming the device, and the third part will be simulating the device. So let us all start with making the device, shall we? Right, so first of all, we need to go to the Tinkercad website by typing on Google Tinkercad, click enter, and then click on this first URL pop up, and then you have reached the Tinkercad website, and then you need to sign up or log in for the first timer. So after you log in, go to the circuit and create new circuit. Alright, wait for a while, and then we have this template which can be used to make our own device. So first of all, we can actually X this. So yeah, we don't have anything. So first of all, we need to have the frame of the device. So what kind of frame you should ask? So in this case, I'm going to use the Arduino kit. So where to find Arduino kit? We need to find it by simply we can find the Arduino kit by simply go to this box, right? Click on it, and then go to status, click Arduino, and then we have this dozen kind of Arduino kit. Click breadboard, and then put it here. Alright, we have our own framework. So yeah, we can zoom in and zoom out by simply use our own scroll mouse, zoom in and zoom out, and then by simply holding the left click mouse to control the camera angle, I think. Yeah, you call it a camera angle, so that you can able to you are able to see the whole device more easily. Now, first of all, we need to add our own component, in this case my component. So my component consists of the resistors, the LEDs, the buzzer, and a ultrasonic sensor. So first we need to add the ultrasonic sensor. So how can we find the ultrasonic sensor? So there are two ways. I'm going to show you the easiest way, which is using this by using this search box, right? Search box, and then type in ultrasonic. Okay, we have this ultrasonic distance sensor, and then we found it, ultrasonic distance sensor. So then we put it on this breadboard. In this case, I'm going to put it on the whole 10, 11, 12 J holes. Okay, this is my first component, and then I need a buzzer, right? The piezo buzzer. So just now I just demonstrate how to find the component in the easiest way. So what about the second method? Is by using this components all box. How to use this box is you need to click on this box and click on basic components, and then you scroll down until you find the piezo. Then you find the piezo, then click on piezo, drag it to your own breadboard. So that is the second method to find the component. So I suggest you to use the first method, which is typing down the name of the component you want to use. So it is much easier and way quicker. to use that method. So where do I put this buzzer? I'm going to put it on pin 23, 23J, 28, 23, 28J. Okay, I'm going to put the buzzer onto the hole. Next, we need the LED. Again, I'm going to use the same technique as the first method. LED, we have 4 colored LEDs, so we're going to put 4. 1, 2, 3, 4. Notice that if you want to know whether which one is anode or cathode, positive or negative pin, just hover your cursor on the leg of the components. We have this cathode and anode. Cathode being the negative, anode being the positive. Now I'm going to put this onto in this hole, which is 34E, and then we have this second LED. Put it 4 gap hole along each other. Again, the same thing as the third LED, 4 gap here, and then the same one as the last LED, which is 4 gap after the previous one. Now we have the 4 LED installed. We can change the color of the LED by simply clicking on the LED, and then this blue box appeared, and it has the option for you to name the LED or to change the color of the LED. So in this case, I'm not going to name my LED, so I can just ignore it. That basically it name it 1, this is the 2, 3, but you can simply ignore it because it doesn't function at all, no function at all. So what are we going to do is that click on this LED. Wait a minute. Alright, and then we need to change the color of the LED. So this one is red, so yeah, that is the right color. The second one will be the orange color. The third one will be yellow color, and the fourth LED will be green color. Right, now we have the 4 LED. Now we need the resistors. Okay, again the same technique we used as the first one. Type in resistor. Now we have the resistor. Again, we need the same amount as the LED. Put it 4 resistor as well. Drag it all 4, and then you've noticed that all of these resistors are in resistance 1 kilo ohm, which is pretty high resistance, you see. So what we need to do is to lower down the resistance a bit by simply changing the unit of resistance to ohm, from kilo ohm to ohm, and change the 1 into 100. So basically you change it from 1 kilo ohm into 100 ohm. Lower it down. We want to make our LED a bit brighter. Right, 100 ohm. Right, so now we have 4 identical resistors which are 100 ohms each. So now what we need to do is to rotate these resistors to make it look horizontally. So now as you can see in the screen, all of these resistors are arranged vertically, right? We want to make it horizontally so that it's able to install on this breadboard. So how do we rotate it? Is by simply clicking on these resistors, any resistors, and then you click R. You type R on the keyboard, on your laptop keyboard. So you type R 3 times so that you can make it horizontal. So 1, 2, 3. 3 times to make it horizontally, right? Do the same thing as the other 3 resistors, which is type R 3 times. 1, 2, 3. Again, type 1, 2, 3. R again, 1, 2, 3. After that, you can simply put your resistor on this breadboard. So in this case, I'm going to put it here for 8A, and then leave 1 gap of hole, leave 1 gap hole as well, I'm so sorry about that, not 4A, 4B. Yeah, leave one gap. 4B, 8B, 4, 8B. Okay, do the same thing as the others. Leave one whole gap, and then we have another whole gap here, and then put the last remaining resistors. Now we have these all components together. Now we need to wire them all. So how do we wire them? At first, we need to determine the pins of the components. So as you can see from this buzzer, okay, let's start with the buzzer first. In this buzzer, we can see there are positive pin and a negative pin. So basically, negative pin must be connected to negative hole. So how do we connect this negative pin to negative hole, this negative hole in this breadboard? So by simply clicking the down hole of this pin, clicking it, you just make a wire out of it. So you make a wire, click one, click twice, click the third, and then click the fourth. Okay, you click every click you make, you just make a bend of the wire, or the junction of a wire. You could say bengkokan in Malay. So tidy it up by simply dragging the shape of the wire to make it more pleasant looking. And then there you have it, your first wiring. You can also simply change the color of the wire. In this case, because of the wire is a ground wire, the negative wire, you can change it into black color because it is black color. Okay, negative wire indicates black color, so it is much more easier for you to know that the wire is a negative wire. Now the next pin of the buzzer is the positive. So in this case, the positive pin buzzer indicates the signal of the buzzer. So what I'm going to do is the same thing, put a wire underneath the positive pin, and then click one, click twice, click the third time to make a junction, and drag it until I'm going to put this signal pin into the pin number 12. Yeah, pin number 12. Click once again, and then we just connect this pin into the 12th pin number 12 in this Arduino kit. Basically, you just connect this buzzer to this kit. Okay, change the color of the wire so that you won't be confused by simply changing it into orange color. Now we just finish wiring our buzzer. The next step is to wire this ultrasonic sensor. So as you can see, there are 3 pins, which are signal, power, and ground. Ground is a negative wire, so we can start it from there first by simply clicking below the ground pin, and then again do the same technique, click once, click twice, and then we simply connect it on top of the hole, which is the negative hole. Alright, you can see it from there. Okay, and then change the color to black to indicate that it is the negative wire. Now the second one is the power. Power means the positive. Okay, P, power, P, positive. Okay, easy to remember. So again, the same technique, click on the hole underneath the pin, power pin. Okay, click it, and then drag it, click once, click twice, and then click the third time, and then connect it into this hole. Okay, because this hole represents the positive hole for this breadboard. So click this one and then tidy it up. Okay, make it more pleasant looking. so that you can easy to check whether the wire properly installed, right? Then change the color of the wire into red, because positive wire indicates red wire, red wire indicates positive wire. Now you've already connect 2 pins of the ultrasonic. Now let's work on the last pin, which is the signal pin. Okay, simply click this one and then click once, twice, and then the third one, and then this signal must be connected to the Arduino kit. So I'm going to connect this pin into the pin number 13 of the Arduino kit, right? Simply tidy it up to make it more pleasant looking, and then change the color of the wire, since it is same as the positive wire, to blue, because why not. Now we need to connect these LEDs and the resistor. Alright, by simply starting to connect this cathode into the negative hole, because cathode is negative for LED. So again, the same technique as the ultrasonic and the buzzer. Press the hole, click on the hole, click once, click twice, and then yeah, to make the bend, to make it more pleasant looking, to make it more easy to observe. Do the same thing as the other LEDs, right? 1, 2, 3. Okay, this one as well. Connect these circuit into the hole of the negatives, so that it able to light up after you finish it. Alright, now we finished wiring the LED. You basically can change its color to gray or purple. I think purple is better. Purple. Alright, now we already wired the LEDs. Now last but not least, we need to wire the resistors. Okay, basically the resistors connected to the LED, each of the LED. Now take the end of the terminal 2 of each LED, right? For example, this first one, the first resistor. Okay, click on this hole underneath the second terminal, then connect it to the pin number 7. Right, pin number 7. Okay, tidy it up to make it more easier to observe. I'm going to change it into brown. I think white. Wait, I think better to use green, because it is more easy to see. Now again, do the same thing as the other resistors as well. Okay, connect this one, click once, click twice, and then do the same thing as the third one. Click once, click twice, click the third time, and lastly for the last LED, click once, click twice. Now we already connect all of the circuits, so this is how it looks. This is how my blood indicator, the blood level indicator, looks like. So now let's move on to coding this device. Next is the coding part. So to code the device, we need to code it so that our device could work properly as intended to be. Alright, so in this case, you want to code it. Click this box located on your upper right upper right window, we click code, and then we have this kind of command. Just throw it away because we don't want to use it. Now first of all, we want to have the variables. Okay, the variables is the thing that you would like to control. Okay, in this case you want to control by using the ultrasonic sensor. You also want to control the sound buzzer, right, and also the LEDs. So first of all, we need to have the variables of the ultrasonic sensor. So by simply clicking variables, and then you don't see anything and other than create variable, then click variable, this command block pop-ups, and then new variable name, we put it as dist underscore sensor, to indicate we are controlling the distance sensor, also known as the ultrasonic sensor. Now we have these all commands. Now we need to have another one variables, which is the limit. We need to have the range to differentiate the lighting of the LED and the sound of the buzzer. If it reach this level, this LED will light up. If it reach another level, another LED will light up. So that is the idea of the limit. So in this case, click create variable, and then this pops up, and then type in limit 1. Click OK, and then first of all you need to do is to set limit. We need to have the limit for red light. So set the limit to the lowest you could. In this case, for my device, I put it 50. And then the second one is set again as well distance sensor to go to input, and then read ultrasonic. Set distance sensor to read ultrasonic distance sensor on trigger pin. Which trigger pin you use to install the ultrasonic sensor. In this case, I'm installing it on pin 13, this blue wire. So put pin 13, get it? Okay, that is the one. Echo pin, same as the trigger in unit cm. We want to use it in unit metric. And then next one, we will use this command, go to output, and then put print to serial monitor hello world. But instead of hello world, we go to variable and put this one, distance sensor. What does it mean by print to serial monitor? Later I will show you. Okay, next one will be the control one. Control, we go to scroll below, and then we use this one, if blank then else. So we fill up the blank with, go to math, click math, and then click this hexagon thingy, put it here, and then change this one to lesser or equal, and then go to variable again, put distance sensor limit 1. So if distance sensor is lesser or equal to limit 1, then we want to make the LED light, the red light, turn on, right? We want to make the red light turn on and the buzzer turn on. So two things you want to control. So based on this circuit, you could see that I already installed the buzzer at pin 12. So go to output, go to set pin, right, this set pin, put it here, set pin 13, because that is where I install wired the sound buzzer. Pin 12, I'm sorry about that, and set it to high. High means that if high, the sound buzzer will produce the sound, but if it's low, right, there's two options whether it's high or low. If high, the buzzer will produce a sound. If low, the buzzer will not produce a sound. Same thing happened to LED as well. If LED is high, which means the LED will produce the light, while if low, the LED will not produce the light, it will turn off. So you get the idea of between high and low. We use high and low to differentiate how it works. Next, we need to make this red light LED to turn on. So by observing the pins, as you can see, this connect to this LED, connected to this resistor, and then this resistor connected into this 7. Now we take this set pin 7 to high as well. So else, what do you mean by else? What if the distance sensor is not less than, it is actually bigger than? So that is mean by else. Other than this, what will happen to the both LED and the buzzer? We could say that it will turn off, right? So put it the same thing, the same set pin 12 to low instead. Set pin 7 as well. Sorry about that, not this one, this one. We use the low high. Set pin to 7. Okay, remember that, huh? Remember the step. Now we already made the first indicator, which is the red light and the buzzer. Now we need to make the remaining 3 LED lights. So again, we need to set another limit, another range for the second LED, which is the orange LED. Again, create variable, type in limit 2, and then set limit to, in this case I would like to make it to 125, 100. Okay, now we set limit 2 to 100, and then go to control, and then put this box once again. In this case, you have set a new range for the second LED light. Do the same thing, go to math, put this hexagon, and then go to variable, take distance sensor, put here, again same thing, make it as equal, lesser or equal, and then this one we put limit 2. In this case it is changed, distance sensor is lesser than limit 2. Then what will happen? The same thing, it will lights up. Okay, go to output, set pin, depending on the orange LED, we can see it is connect into this wire, connect here, go to the resistor, and then it connects to 6. Go to code, set pin 6 to high, and do it otherwise for else. The same thing, 6 to low. Again, repeat the step for the third LED. Okay, go to variable, and then click create variable, do limit 3 this time for the third LED. Put set limit 3 to a higher value, which is 225. I think that is too much. And then go to control, go to this, again the same box, go to math, take this hexagon thingy, and then go to variable again as well, and then go to distance sensor, put it here, lesser or equal to limit 3. It will lights up the third LED bulb, which is the yellow bulb. So take the same step again, take the output block, set pin again observe, which is pin number 5. Set pin number 5 to high, and then otherwise for else set pin number 5 to low. Alright, and lastly for the third LED, the fourth LED, which is the green LED, do the same thing. Create variable limit 4. Alright, set limit 4 to 225. The same thing, right? The same thing as the limit 3, but this time, all right, this time this is different from the previous one, which is we put the same thing, the math, the hexagon thingy, the same thing, distance sensor, and the limit 4, but this time we want to make it larger than the limit 4, which means put it bigger than limit 4. So what will happen if it reach above to 225 cm? So we will make the same thing, turn the light LED on. So do the same thing, output set pin, the green LED will be located to 4, connected to pin 4 to high. Do the same thing otherwise, set pin to low, and yeah, there you have it. That the whole coding of this blood indicator. Yeah, I know it's a bit long, but yeah, try it, it is worthwhile. So next we're going to the next and last part, which is the simulation. We're done making the coding. Now let's all try to simulate the device by simply closing this code window, okay, clicking this code, and then zoom out to see the whole circuit that you have made. Okay, and then by clicking this start simulation, you are able to simulate your own device, whether or not your device is able to work functionally or doesn't work at all. It depends. So we try to start our simulation, and you notice that this yellow light emitted, and then in order to control this device, by simply clicking on this ultrasonic sensor, you can see there is a toggle. Clicking on this ultrasonic sensor, there is this circle that is basically the distance of the object. Okay, the further the nearer. Okay, the idea of this device, which is the blood level indicator, is that if it's far or it is abundance, it is enough, then as you can see, the green LED light will emit it or turn on, shows that it is in a good condition, the patient is in healthy state, has a good blood level. But what if the blood level reaches a certain period, the certain level, which is, in this case, if you refer back to the code, I set it to 225. So what will happen if it reaches 225 and below? As you can see, notice that upon reaching below 225, yellow light is turned on, indicating that this patient has decreased in low level. Right? So what you're going to do is that this patient needs to go to see a doctor. Okay? If the patient ignore this, then it will decrease again. Decrease until it reach the second level, the next level, which is the orange bulb or orange LED. As you can see, these two LEDs are now turned on. Basically, in this level, the blood level is very lower than the previous one compared to the yellow light bulb only. In this level it is much more lower than the previous one. So in this level the patient should seek a doctor. Okay, but what about if the patient manages to ignore once again? So the patient once again ignore the blood level, ignore his blood level, then it reached this certain level, which is the red light bulb, the red light LED, and also along with this piezo buzzer producing the sound. So what does that mean? That means the patient must seek a doctor as soon as possible, because the blood level inside his body is so low that it must be examined quickly as possible, whether or not it should be given medication or give some therapy or examination by the doctor itself to get to take care of the patient, because it very low blood level is not healthy actually. So get the idea. So if it reach very low blood level, red light, orange light and the yellow light will turn on along with the buzzer producing a sound to alarm the patient that this condition is critical and serious, and it is must to see a doctor. So yeah, this is the idea of my blood level indicator. Okay, if it's normal, then green light pop up. If it's a bit decreasing than the normal one, it will yellow light will turn on. If it decrease more than the previous one, the orange LED will turn on. But if it reach the critical condition, the worst condition out of all, the red one will light up along with the buzzer to alarm the patient that this need to be taken seriously as well. So yeah, this is the idea of my device using this Tinkercad software. So yeah, wait, change the name yet. Blood level indicator. Yeah. So yeah, that's it. That is my device that I made. Thank you for watching.